All right, 92, Unit 3, Lesson 4. This comes out of the book on quadratic formulas, Section 9.4. Students will be able to solve quadratic equations using the quadratic formula. So we have been solving quadratics by factoring. What else? Square root property, or the even root property. Sorry for the handwriting. That is proper. I'm going to go there. And completing the square. Okay, so we're going to add to that. Sorry, if you can read that. We're going to add to that using the quadratic formula. Okay, so this is your quadratic equations in standard form, or some books call it the general form, right? They're going to use this A, B, and C to create, actually they use completing the square as a way to turn this all around to the quadratic formula. If you go in your book on that page, it'll show you how they did that. Using these A, B's, and C's, they come up with the quadratic formula in that form. You need to memorize that, okay, for your other method for solving quadratics. So if you notice that this little part right here is the part of the quadratic formula that's called the discriminant. The other thing we're going to use is the vertex. If you're making a flashcard, there's a vertex formula. Sorry about that. That comes from what's left. This little part over here is the vertex formula, negative b over 2a, and that's going to come up also in the very last section, I believe, 9-11. Yeah, the next one, believe it or not. So we're going to use so this general form can be turned into the quadratic formula, and then the quadratic formula splits into two parts called the discriminant, and the other is called the vertex formula, okay? And the vertex formula we're going to talk about in 9-11 or lesson 5, okay? All right, so skill 1, compute the discriminant to determine the number and type of solutions in a quadratic equation without actually going through the whole formula, okay? Remember, some parts of this lesson or this unit, you've had one answer solution. Sometimes you have two. Sometimes you have to check for things. The discriminant, if you put your quadratic in the quadratic formula and calculate out just the discriminant, you can find out the number, how many solutions you have, and what type of solutions they are, okay? So step 1 is always to identify, once it's in general form, what is your A, what is your B, what is your C, so you can use this formula here, okay? Calculate that out. When you get a value, it's going to either be positive, negative, or 0, right? You're going to get a negative 12, a positive 3, or a 0. That means something. When the discriminant is positive, that means you have two real solutions. When the discriminant is negative, you're going to have two complex solutions. That means they have an I, okay? And then when it's 0, you're only going to have one real solution. So if you think about it, real is everything else that isn't a complex. So we're talking irrational and rational. So we could have a radical sign in our answer. Make sure everything is simplified as much as possible. But at least the discriminant gives you an idea of what to expect after you crunch through the numbers, okay? So here's some examples using the discriminant to determine the type of solution of the quadratic equation. So number 1, there's a quadratic equation. Notice there's nothing in front of the x squared. By now you know nothing in front is actually 1 in front, right? There's a numerical coefficient of 1 that you don't see sitting there. The b is your negative 5, and your c is the 3, okay? So memorizing the discriminant formula, we put the -5 in for b. Don't forget the sign. Don't forget the parentheses. Remember, -5 squared is not the same as -5 squared with the parentheses. This is -1 times 5 times 5, which is a -25. This is a -5 times -5, which is a positive 25. So it's very important. This is the most common mistake made in the quadratic formula, I believe, because right here is a b squared. So anytime you're using the whole formula or just the discriminant, we want to make sure that you're putting in those parentheses when you have a negative number, okay? So -5 times -5 is a positive 25, and then A is, notice there's always a -4. That's important, okay? So -4 times A, which is 1, times 3. -4 times 1 times 3 is a -12. So then orders of operations, notice what I did first. I did this and then this whole thing, and then I subtracted, okay, and got a positive 13. A positive 13 means there will be 2 real solutions to this quadratic after I use the quadratic formula. Okay, we'll do that in a minute. So right now I'm just checking the discriminant to get an idea of what to expect for my solutions. Okay, so here's another one. A equals 1, B equals -3, C equals 5. So B squared, write it all down, right? Show your work, show the substitution. There's my B squared, -3 times -3. Wait. Nick, what a minute. Sorry. I get talking and forget what I'm doing. I'm supposed to. So, sorry. Let's start again. Sometimes, until you get it memorized, write down the discriminant equation so you can follow it. So this is a -3 squared minus 4 times 1 times 5. Okay? Just copy that down so you remember as you're going, and that'll help you remember if you write it every time. So -3 times -3 is 9, minus 20. So obviously this is going to be a negative number. So this has a negative number. So negative numbers are what? Go back up here. Another thing you need to try to remember would be 2 complex. That means 2 of my answers are going to have, I'm going to have 2 answers, and they're going to have i's in them. Okay, if I do it correctly. 3a is 1, b is -2, c is 1, b squared minus 4ac. So b squared would be -2 squared minus 4 times 1 times 1. Yes, I write it all out to show my work. Let's see, this would be a 4 minus 4. This would be a 0. When I get a 0 as a discriminant, that means I have one real solution. Okay? All right, solve quadratic equations using the quadratic formula. Now I want to do the whole thing here. So if you notice, these are the same problems. Here and here. Okay, so this, and this are what I'm expecting if I do this correctly. Okay, so A is 1, B is -5, C is 3. It's a good habit whether your instructor requires it or not. Write that down. And then the quadratic formula. Quadratic formula has an x. Don't forget, we're always solving for x. Then it has a b. Look at it, go back up here. It has a -b. So whatever b is, in this case, our b is negative, so it's a double negative, plus or minus the square root of b squared, right? The discriminant, b squared. So -5, use those parentheses. 4 times your a times your c over to a. Okay? That's negative is positive. Plus or minus stays there. And we calculated our discriminant above, which is 13 over 2. So our final answer is 5 plus 13, square root of 13 over 2, comma 5 minus square root of 13 over 2. Those are two real solutions. Remember, real includes rational and irrational. The square root of 13 is irrational, but it's also real, as in I don't have an I don't have an imaginary number in there. So these are two real solutions for this quadratic equation, okay? And that's what we expected because my discriminant was positive. All right, so let's try the next one. Let's do it in a different color here. All right, so A equals 1, B equals negative 3, C equals 5. So X equals, some people say opposite B. I just like to put negative B, plus or minus, and this was times 2A, plus or minus the square root. I did the discriminant right up here. It came out to a negative 11, so I'm just going to use that, okay? All right, so clean this up. This is going to be a negative, which is a positive, plus or minus, what is this? This is, we got to take the square root of negative 1 out. That's an I, so I square root of 11 over 2. So you may have to put as an answer I square root of 11 over 2, comma 3 minus I square root of 11 over 2. And did we expect an I? Yes, we did, because our discriminant was negative. So we have two complex solutions. In other words, I have I's in my answer as required. Okay? As the discriminant told me it was going to be. All right, number 3, not X. A is equal to 1, B is equal to negative 2, C is equal to 1. So X equals opposite B, which is negative 2, plus, I don't have any positives. Negative's the harder one, so that's probably why it's on there. And then square root of, up here I did the discriminant. The discriminant ended up being 0, so I'm just going to throw that on there. And 2 times A. So this is going to be negative is a positive. And that's just 1, and that was what I expected, was one real solution. Okay?